Today, we're continuing to talk about the states of matter. So I just wanted to do a quick review. So what do you remember that we talked about last time about states of matter?
Matter is anything that takes up space and has weight or mass.
Okay, that's true. And it can also exist in several different states, right? And what were the three main states that we talked about last time?
Liquid, gas, and solid.
Solid, liquid, and gas. What made the difference between one and the other? It's how the what were arranged.
Way the molecules are.
Right. How tightly packed the molecules were, right? If the molecules are packed pretty tightly and they can only vibrate kind of in place, then that is a what?
A solid.
A solid. If they're able to flow past each other, then it's a
liquid.
Liquid. And if they can go off wherever they want, then it's a
gas.
Gas, right. And understanding these states helps us understand the behaviors of the things in our world, right? So those are the three main states of matter, but there are other ones. Another one that you might be familiar with, or at least have heard about, is plasma. So plasma is when you take a gas and you heat it a lot. So it's a superheated, energized gas where the particles or the molecules and the electrons become ions, or the molecules become ions, and the electrons get so excited that they start giving off light. So they create a luminous state. Luminous means light, with light. And so when they start giving off light, that's what we call plasma. And you may have seen it, depending on where you live, in the auroras. So either the aurora borealis or the aurora australis, or at least you've probably seen pictures or videos of it. And that's caused by plasma, that beautiful aurora. Plasma is also found in man-made things, so like neon lights. That's what causes the glowing in the neon lights, is plasma. And it also happens in nuclear fusion reactors. So plasma forms also when microwaves, just like you have in your microwave, can excite electrons so much that it causes ionization. And we haven't talked about that. You may not know, unless you've studied chemistry somewhere before, you may not know what an ion is, and that's totally fine. We will get to that. So it can happen. I wouldn't suggest doing it. This is a demonstration only. Unless you talk to your parents and they say it's okay, please don't try to do this. But I'm going to show you plasma in my microwave. It's going to create hot spots in the grape, and it's going to actually create plasma, and it's super cool. It smells lovely also. So you won't have to experience that. But I'm going to do that now and show you. So I'm getting grape. I'm going to put it on a plate, and I'm going to cut it so where just a little piece of skin is holding it together. Then I'm going to put it in the microwave. So that is plasma that it's creating there. Okay, so besides, obviously a grape letting off light, kind of what does it look like? Did it look a little bit like lightning in the microwave?
Yeah.
Yeah, it looks a little bit like lightning, and that's because lightning is also plasma. So that light that it's giving off just shows that it's superheated, excited particles. So now we're going to do our experiment where we look at different ones that maybe don't fit super nicely into one of those three categories. We're not going to be working with plasma today, besides what I showed you in the microwave. But I wanted us to talk about, is it liquid, solid, or gas? So if you're not doing it with us today, maybe you have messed with shaving cream before. So I'm going to show you what it looks like. So I've got my plate. I'm just going to spray some shaving cream on here. So what does that look like to you? Does that look like a solid, a liquid, a gas? What would you say?
To me, it looks like a mix between a liquid and a solid.
Mix between a liquid and a solid, okay. So what do we know about solids as far as their shape and size?
They maintain the same shape even in different containers.
Yep.
And they maintain the same shape and size.
Right. So one of the key characteristics of solids is that they maintain the same shape and size. Now, if I jiggle this, you can see it moves a little bit. What about liquids?
They kind of like change their shape to fit in whatever container they're in.
Right. And this actually is flat on the bottom. As I move it around, it can move some. And as it sits here longer, it's going to end up spreading a little bit more. If I touch it, I'm able to move it around quite a bit so it doesn't keep the same shape, but it also doesn't flow freely and fill up the plate, right? What about gas? What do we know about gases?
It'll take the shape of anything it's in, it'll just spread around.
Okay, so if it's in a closed container, it spreads out to take up the whole container. If it's not in a container, it spreads wherever it wants to, right? So that doesn't really look like a gas either. So if I put my penny on it, I think I have really stiff shaving cream. It's not really sinking into it, but you can see it moving around. If we let it sit here, which we're gonna do while we do the other things, and we'll come back and check on it, we'll see what happens as it sits here. So that's not really super well defined as far as, is it clearly a liquid, clearly a solid, or clearly a gas? It's kind of hard to tell, right? It is what we call a colloid. So colloids are really cool substances that combine different states of matter, showing the properties of more than one state at a time. So if we go back to our shaving cream, it's actually a mixture of a couple, which is what you said, right? You guys guessed that already. So some examples that we have there. So if you see in the picture, there's a marshmallow. So a marshmallow is actually a mix between a solid and a gas. So you have a solid substance, but there's gas in it. So if you cut a marshmallow in half, you can actually see the air bubbles that you're taking apart. So that's what that is. Up in the little clear bowl, there's soap suds, and that is a gas and a liquid that has an outside that's a liquid filled with the gas. And then you have pudding. It's actually a solid that soaks up liquid and keeps liquid inside of it. So those are the three combinations. We have a solid and a gas, a liquid and a gas, and a solid and a liquid. And those are all called colloid mixtures. It's where one is suspended in the other throughout. So, is it solid, liquid, or gas? Part 2. We're gonna look at a different thing. You may have made this before at your house or something, but if not, we're gonna make some today. For this, you're going to need your cornstarch, a bowl, an electronic balance or a measuring cup. You're gonna need some water. You can use food coloring if you want. And then you would need a spoon to stir it with. We are gonna put 125 grams of cornstarch into our bowl. So what is the first thing that I need to do to my electronic balance?
You need to cut it on.
Turn it on.
And then put the bowl on the scale.
Okay.
And then zero it out.
Right. So push the tare button. And that's going to take it down to 0. And we want to make sure that it's set on what kind of measurement? Grams. 125 grams of cornstarch. So that's what I'm going to start with. And then I'll actually put it in a measuring cup and tell you how much you would need if you were using a measuring cup. That's going to be quite a bit. And thankfully I bought another container. Okay, I'm at 111, so I guess I'm going to go a little more slowly now. 120, 123, 125. Okay, and so I'm going to measure that and see how much that would be in cups if you were using a cup. All right, if you're measuring it with a cup, you would use 1 cup of cornstarch or 125 grams. And then, we don't need our scale anymore. Then we're gonna measure 100 mils of water. So, I'm using my graduated cylinder. I'm gonna go up to the 100 mil line and I'm gonna make sure that what is true. And make sure the bottom of the meniscus is sitting right on the 100 mil line. To do that, I'm gonna have to get down at level. Maybe just a hair more. There we go. So 100 mils. The measurement in cups is not super exact. It's a little under half. If you're not measuring with a graduated cylinder, I would start with maybe 1/4 of a cup and add a little bit at a time. So we're gonna put that in there. And stir it up. So I'm gonna go ahead and add the rest of it since I did measure with my 100 mil graduated cylinder. I'm gonna stir it. I'm gonna go ahead and add my food coloring because I think it'll make it easier for you guys to see. If you're doing it, you can add food coloring or not. So I actually didn't even realize I'm doing the same color as the picture there. I added 4 drops of food coloring. It is really hard to stir because of one of the crazy characteristics of this type of substance. I'll show you what it looks like. It's really fun. A little messy, but really fun. So I've got my oobleck here. And what does it look like in the bowl? Well, I just spilled it so you could see. Not on purpose. What state do you think that is?
It kind of looks like the mix between the solid and the liquid.
Okay.
But I can't really tell.
It really looks like a liquid. It moves around the bowl very easily. It pours clearly, as I showed you accidentally. But look what happens when I start to stir. I hope that you can see it. It's hard to do at an angle because I'm afraid it's going to pour out of the bowl onto my computer. If I hit it though, can you hear it? So when I hit it, it acts like a solid, but when it's just moving around the bowl, it looks just like a liquid. It looks like I poured heavy cream or something in there. It looks just like a liquid. But if I hit it, it's like a solid. It's really, really bizarre. It's crazy. Like, it's super crazy. So, oobleck is what's called a non-Newtonian fluid. It doesn't act like normal fluid. It behaves uniquely. When moved slowly, it looks like a liquid, just like I was showing you moving it around in the bowl. But when force is applied to it, it feels like a solid. It's very strange, not something that we usually experience. So it's called a non-Newtonian fluid. States of matter can transform with temperature and pressure. So you've seen a glass of ice water sitting out and the ice melts and becomes liquid, or you put a pot on the stove and the liquid starts to turn into steam. So you've seen changes with temperature. As you go throughout the next few days, pay attention and see in your environment different examples of different types of states of matter. And pay attention and think, is this a solid? Is this a liquid? Gases are going to be the hardest ones to see because you can't see them. You have to just observe what they're doing, right? Unless it's like steam or something like that, you can see that. But most of the time, gas is invisible because it's so spread apart. So That's my assignment to you for the next few days, is to observe around you and see in your environment the different states of matter and see what you can come up with. If you want to do the shaving cream, if you let that sit out for a day or two, you'll actually see that those air bubbles start to pop and you'll end up with a liquid. So I didn't talk about what your shaving cream was. Shaving cream is actually a liquid and gas mixture. So if you let all the gas start to escape by leaving it out, the temperature will go up and it'll just start settling out. The gas bubbles will pop and you'll end up with liquid on your plate. So just observe some of those things throughout the next few days. Next time we'll be talking about changes in phases. So that's why I want to make sure that you observe things around you, the different states that things are in, and also how they change from one state to another. So pay attention to that, because next time we'll be talking about phase changes. And then we'll move on to conservation of matter.